Okay, we're back again. We're ready to learn about de Moivre's theorem. The cat is eyeballing me like he's plotting something very evil, and that's got me on edge a little bit. But whatever, if you hear me yelp loudly in the middle of the video, that's probably what happened. Then you might see a black mass go flying across the screen. And that would be a cat ceasing to exist anymore. But let's hope that doesn't happen. Okay, so I'm gonna make up three different complex numbers, and I'm gonna call the first one R1 cosine alpha. Okay, so alpha would be an angle. So R1 is the radius, and then alpha is gonna be the angle. And I want to cube that. Okay, I don't even need to call it R1. We'll just call it R. You know what? It's kind of dumb for me to have used alpha. I could have just used theta, but whatever. I've used alpha now, so now it's alpha. All right, I want to cube this number, so I want to bring it to the third power. So that means r cosine alpha times r cosine alpha times r cosine alpha. Okay, well, we just learned how to multiply complex numbers in trigonometric form. Here we have three of them, but that's okay. We'll multiply the r's. R times r times r, that gives me r cubed. And it just occurred to me that I put cosine on all these, and they're supposed to be cis. My bad. Those are all cis's. Okay, so r times r times r would give me r cubed, and then cis, and then we're supposed to add those angles together. Alpha plus alpha is 3 alpha. So look what happened here. When we cubed this number, really all we're doing is taking the r and raising it to the third power, and we're taking the angle and multiplying it by the power. So we did r cubed, and then we did alpha times 3, and this is a very simple theorem that is attributed to this guy named de Moivre. He was French, just like René Descartes, and this is called de Moivre's theorem. It's not de Moivre. This isn't Joyzy. It's de Moivre's theorem. Okay, the cat is now on the table and he's prowling. Get off. Okay. I'm glad that you can't see that. So very simply, let's say let's do a radical for our radius. Let's say, even better, let's do this. Let's say we have a radius of 2 root 2 and my angle is 2 pi over 5, okay? So I've got 2 root 2 cis 2 pi over 5. And we want to raise that to, let's do it to the 5th power. So we're going to do it to the 5th power. Okay, de Moivre's theorem makes this very easy. It says all we have to do is take 2 root 2 and raise that to the 5th, and then take our angle and multiply it by 5. And that's all there is to it. Now let's talk about this 2 root 2 raised to the 5th power, okay? So this is a 2 to the 1st, obviously. This square root of 2 is 2 to the 1/2. So if we take 2 to the 1st and multiply it by 2 to the 1/2, the rule is that we're supposed to add those exponents. So an exponent of 1 plus an exponent of 1/2 would be 2 to the 3/2. Now we're raising that to the 5th. Cis 2 pi over 5 times 5. Okay, now 2 to the 3/2 to the 5th would be 2 to the 15/2. Cis, and that's really just 2 pi. I've done everything right here, right? I think I have, yeah. Okay, 2 to the 15/2, I need to come over here and use this space. 2 to the 15/2 is the square root of 2 to the 15th. Cis 2 pi. The square root of 2 to the 15th would be 2 to the 7th root 2. What is 2 to the 7th? I don't even know what that is. I should know that. I don't know what it is though. It's 128. So that's 128 root 2 cis 2 pi. I feel like I did something wrong, like that's unreasonable or something. But I guess it's not. I guess that makes sense. Okay, that would be the polar form of the number. So we raised a complex number to the 5th power. We just raise the r to the power and we multiply the angle by the power. Now suppose they wanted us to change that back into standard a plus bi form. We didn't really do this before, and I need to show you how to do that. Okay, so 128 root 2 cis 2 pi. So the way that works is all we have to do is remember, that's a 2. All we have to do is remember what the cis means. The cis means cosine of the angle plus I times the sine of the angle, right? That's what cis meant. Okay, now everyone, what is cosine 2 pi? You should remember that that is 1. And then what's the sine of 2 pi? The sine of 2 pi is 0. So we have a 0i there. So this is just a 1. Multiply that out, and that's really just 128 root 2. So it turns out that that complex number there is just a real number. But we just changed it back into standard form. Really what we're going for here is how to use de Moivre's theorem, okay? In the next video, we're going to learn how to take de Moivre's theorem to the next level. See you then.